Alright class, I'm back on page 240. Welcome to video 3. Basically, here's a little handy graph that'll help you figure things out. If you start with the mass of a compound in grams, and you want to get to the number of molecules or formula units of the compound, you use these conversion factors. Basically, 1 over molar mass of the compound gives you the compound in moles. And then you go moles times 6.022 times 10 to the 23rd, that's Avogadro's number, to give you the number of molecules. That should be familiar from chapter 2, I think, or 3. Or let's say you're going for the mass of element. Let's say you have the mass of the element in compound, and you want to find out the number of atoms of the element in the compound. We just basically, you use the molar mass to come up with the amount of moles, and then you go times Avogadro's number to find out the number of atoms. Hey, write this down in your notes, draw it out, make sure it's clear. That way you can use it on our quiz and that we can study for your test. This is something you need to have in your head for test time. Anyway, let's do a quick practice problem. So please take out your different color pen. Oh, wait, let's read a little bit more. Molar mass as a conversion factor. Just what we looked about up ahead. The molar mass of a compound can be used as a conversion factor to relate an amount in moles to a mass in grams for a given substance. Recall that molar mass usually has the units of grams per mole. To convert a known amount of compound into moles to a mass in grams, multiply the amount of moles by the molar mass. For example, the amount in moles times the molar mass will give you the mass in grams. Conversions of this type are summarized in figure 4. That's what we just looked at. All right, sample problem H. Yeah, I can't wait to do sample problem H. Me too. All right, so let's do it. What is the mass in grams of 2.5 mole of oxygen gas? Well, first, with your different color pen, sample problem H. All right, and here we go. You're given, what are you given? 2.50 mole of O2 gas. How do I know it's O2? Because I remember from a previous chapter, oxygen gas comes in O2. What is the unknown? Mass in grams. Okay, so what's our plan? Oh, remember the plan. Well, we're going to go from moles to grams. And what are we going to use as our conversion factor? Molar mass. Pretty simple. If you don't remember exactly how to do that, well, you can do you can use this right here, right? Mass of compounding. We're starting out with the amount of compound in moles, okay, and we want to go to the mass. So we're going to use the molar mass of the compound to get it. That's exactly what I said. All right, let's move on with our sample problem. So, oh, look, that's exactly what they did. To convert the amount of O2 into moles to mass of O2 in grams, multiply by the molar mass. And here's how they did it. Amount of O2, okay. Let's go to the next page, please. Page 241. Still on sample problem H. And let's take a look how they did it. Well, first they say, first the molar mass of O2 must be calculated. All right. So remember we just did molar mass. We have O2. Basically, there's 2 oxygen atoms in that. Each oxygen atom has 16 AMU about. So that means that has about 32.00 AMU. You can see that Mr. Worley kind of skipped writing this all out. If you understand how Mr. Worley skipped that, move on. If you don't, write it out yourself. Now that we have the molar mass, we can go ahead and do the calculation. So we start out with, our given was 2.50 moles of O2. Now we're going to use our molar mass. That's what we just figured out. And we know that 1 mole of O2 is equal to 32.00 sorry, grams. Did I say AMU? Grams. And we do our math, and what do we come up to? We come up with 80 grams of O2, just like that. So that's how we found out the mass in grams of 2.5 moles of O2 gas. Okay? The answer is correctly given to 3 significant figures and is close to an estimated value of 75 grams. Why 3 significant figures? Well, check it out. In our given, we were given 1, 2, 3 significant figures, and in every number that we used, we had at least 4 significant figures. 1, 2, 3, 4. Remember, when multiplying, you apply the least. You apply the least amount of significant figures. So, yeah. Please move on to the next video.